Let's estimate the power factor for a 480 volts three-phase service that includes several motors, specifically 450 horsepower motors, two 100 horsepower motors, and one 500 horsepower motor, along with 100 kilowatts of electric heat and 15 kilowatts of high-intensity discharge lighting fixtures. A rough estimate for the overall power factor would be between 0.85 and 0.90. Modern motors often have built-in power factor correction, typically using capacitors. These capacitors reduce the reactive power component, leading to a higher overall power factor than if the motors weren't corrected. To estimate the power factor, we can use the formula power factor equals real power divided by apparent power. We need to calculate the real power. We assume the electric heat and the high-intensity discharge lighting fixtures have a power factor of 1, meaning they contribute only real power. To calculate the real power from the motors, we use the conversion 1 horsepower equals 0.746 kilowatts. The calculation is as follows: 4 times 50 horsepower times 0.746 kilowatts per horsepower plus 2 times 100 horsepower times 0.746 kilowatts per horsepower plus 500 horsepower times 0.746 kilowatts per horsepower plus 100 kilowatts plus 15 kilowatts. This results in a total real power of approximately 550 kilowatts. To estimate the apparent power, we assume a power factor of 0.85. Apparent power is calculated as real power divided by the assumed power factor. In this case, 550 kilowatts divided by 0.85, which equals approximately 647 kilovolt amperes. Therefore, the estimated power factor is calculated by dividing the real power by the apparent power. 550 kilowatts divided by 647 kilovolt amperes, which is approximately 0.85. It's important to note that this is just an estimate. The actual power factor may vary depending on the specific characteristics of the motors and other equipment connected to the system. Factors such as motor loading, motor efficiency, and the specific type of high-intensity discharge lighting fixtures used can influence the actual power factor.